Hello everyone. Today I'll be talking about TikTok's recommendation system. TikTok has now become one of the most popular social media platforms in the world, and its powerful recommendation system is a big reason for that success. Let's take a deep dive into how this system works. First, let's start with traditional recommendation systems. The most widely used method in the past was collaborative filtering. This method is based on user-item interactions. For example, if user A likes gaming, history, and sports, and user B likes gaming, history, and art, then the system might recommend the sports content to B, since user B's interest closely align with user A's. However, this approach has its drawbacks. It performs poorly with new users or items, and it tends to amplify the popularity of already popular items. In 2016, Microsoft introduced deep crossing, and Google introduced the wide and deep. 3 years later, Facebook presented Deep LRM, which is Deep Learning Recommendation Model. This marked the era of deep learning in recommendation systems. Deep learning models, with their powerful ability to learn, can use embeddings to capture relationships between sparse features. Compared to traditional models, they can understand more complex feature interactions with their strong generalization and precise prediction capabilities. Deep learning models have become the core of modern recommendation systems. Naturally, TikTok's system also relies heavily on these models. TikTok's recommendation system has two core parts: the two-tower model for record stage, and the wide and deep model for the ranking stage. Before introducing the models, let me explain the two-stage framework. Here's an example. In the record stage, the system selects a small subset of videos that may match the user's interest from a massive video pool. Imagine that there are 10 million videos. This step picks 100 videos that might be relevant to the user. Then, in the ranking stage, these 100 videos are sorted and scored to produce the top 5 final recommendations that appear on the user's homepage. The two-tower model consists of two neural networks: the user tower and the content tower and the item tower. In the record stage, the user tower maps user features to a vector space, and the item tower maps video features into the same space. The similarity between these two vectors is then computed to find matching videos. It's important to note that this similarity is not cosine similarity, but rather the inner product of the vectors. This is because the magnitude of the content vector can reflect the video's popularity, something cosine similarity would normalize away. Now, let's move on to wide and deep model. It has two components: the wide component and the deep component. The deep component is a deep neural network that learns complex relationships between sparse features through embeddings. However, since its outputs are always non-zero, it can sometimes overgeneralize and treat unrelated features as if they are relevant. That's why wide component is introduced. This linear model can memorize specific feature combinations, thus addressing those overgeneralization problems effectively. Next, I will show you a simple TikTok recommendation system that I've implemented in Python. As seen in the diagram, this system consists of three parts: the two-tower model, the wide and deep model, and the information co-com prevention. as in this code, in this simulation, we assume the platform has 50 videos across 5 categories: sports, game, history, music, art. User features include age, gender, device, preferences, watch history, likes, favorites, comments, and video features consist of completion rate, duration, likes, favorites, category, comments. We randomly generate user and video data and use them to train models. It's here. We use random initialization to generalize the user and video data here. And once the code demonstrates the architecture of the two tower and the deep and wide model here. This is the neural network architecture of the two model. Once trained, the models are used to recommend videos to each user. I think it's here. After the training, we can use these two models to recommend videos to the 5 users. In the record stage, 20 videos are selected and then ranked to pick the top 5. You'll also notice the information COCOM prevention mechanism, which ensures that 1 to 2 videos from outside the user's preferences are included. For the results, let's wait. Yeah, yes, that's the result of this simple recommendation system. Okay, now let's move on. In conclusion, TikTok's massive popularity is inseparable from its excellent recommendation algorithm. It not only delivers prices recommendations using deep learning models, but also incorporates mechanisms to prevent user fatigue and encourage exploration of new interests, ensuring sustainable user engagement. Thank you all. That concludes my presentation.